So here's today's issue with pole play. We have the line 1 breaker that is a shore power breaker. It gets 120 volts from the shore power. With the shore power connected to the boat, we're not getting this light on. With this breaker on, we're not getting any power transferred down here to the shore, the line 1 outputs, which would be the port outlets, starboard outlets, all the electrical outlets. So what we're going to do is we're going to test this breaker and likely have to replace it. I've already disconnected the shore power, so there's no shore power 120 volts going into this circuit right now. So to test this breaker, we're going to take our voltmeter here and we're going to put it on ohms. Kind of looks like that speaker down there at the bottom. That's ohms, and what we're going to do is check for continuity across the breaker. Now right now the breaker is on, all right, and what we should get is I'm going to put a probe here and I should get a buzzing sound on this nut here, this screw here. Now as you can see, I've got my test lead wedged in here between the wires and the screw on the breaker, and what I'm going to do is test these two screws on the other side of the breaker, and what I should get if we have continuity with the switch on is a buzzing sound. That's the buzzing sound. Okay, so we have continuity with the top pole of this switch. Now as we have continuity on this top pole here, and you can hear it buzzing, that's with the switch on. Okay, this is what happens when I flip the breaker to off. Okay, which is what's supposed to happen. There's not supposed to be any current or continuity between these two poles. All right, so I'm gonna flip that back on. Now as you can see, there's a lot of sand along these wires in here. There was previously a lot of corrosion along these plates and things like that. We're eventually going to have to replace all of those, but that sand is due to little L taking the biggest L of its life and sitting on the bottom of the ocean. Now replacing a breaker is pretty easy. Okay, replacing a breaker without killing yourself is pretty simple too. You just have to be conscious of whether or not you've got power to the panel. 120 volts will kill you. 12 volts, that ain't gonna do nothing. So we make sure that we've got the panel disconnected and that there's no voltage going to this panel while we work on it. I do have a 120 volt tester that just makes a loud noise. If there's a kind of a beeping noise like that, if there's 120, it'll scream. And so we put this up here and just feel along the top here, and there's no 120 that we're getting, and I know that because I disconnected the shore power, but that's how you would test and see if you've got live 120 to your panel. Now the first thing that you have to do to replace this breaker, it's a 2-pole breaker, you have to undo these 4 screws on the face of the panel. I'm not sure why they do this, but they put 2 of these screws pretty much under this bar, I guess just to make it a pain in your ass, but we'll get that disconnected and show you what's going on the back side. All right, as you can see, I've gotten all 4 of the Phillips head screws removed, and we're getting ready to pull this breaker from behind. So when we put the panel down, we're right here on the top. This is the top breaker, line 1, shore power, and what you'll notice is that on the second pole there's what we call a common bar that goes down and feeds the generator poles, at least one of them. And so we got to disconnect that and get it out of the way so that we can get this line 1 breaker free. So just a note, to get this line 1 breaker out, it's not necessary to absolutely remove this common bar. All right, what we're going to do is we're going to loosen this Phillips head screw here, take this Phillips head screw off, which is actually on the breaker for line 1. All right, and then just lift it up and the breaker should be able to come out. All right. All right, so what I've done is I've loosened the screw here, and we'll get ahead and get that out. If it decides it wants to come out. And as you can see, the common bar will raise up off of the pole, actual pole of the breaker, to give us room to get it out. Now, if you can't get it out, then you got to undo these other two and pull the whole thing off. But I think I'll be able to finagle it and get it off without taking that completely off. But we got to get this screw off and these two Phillips head screws back here too. So I'll do that and get back with you. Now, one important thing you need to do and be aware of before you take this apart is that you want to, what I do is I snap a picture of where each line is positioned on the breaker. Okay, as you can see here, there's a blue tipped white wire, a yellow tipped white wire, and back here on this other pole, that's the hot wire that has a blue tip on it as well. But I've got pictures of all this because it's going to be important that you put this back in the orientation that you had before you take it off. And same thing on the other side. Over here we have basically the red cap wire goes to the shore power light, the indicator that lets you know that you have shore power on. Likewise, there's a reverse polarity light and two white wires going off of those poles as well. And then there's a hot wire that goes basically down to the other line leads on a common bar back there. But you want to make sure that you've got a picture of the orientation of these wires coming off of your breaker so that you put it back correctly. So I've basically freed the breaker here by removing the 4 Phillips head screws. And like I said, basically I have pictures of the orientation of the wires. But since this is a double pole breaker, what we have here is a connecting bar that connects one part of the switch to another part of the switch down here. And what has to happen is I have to, and I apologize for all the movement of the camera, but I have to remove that little locking pin, okay, in order to free these two from each other so that I can get the breaker out. All right. Now, chances are you're never going to find this damn thing when you pop it out, unless you do it extremely carefully. But the new breaker comes with replacement locking pins, so I don't really worry about that. And see, you see how that came off? Now, there's one on the other side that I'm going to have to put the camera down to get to, and then this pin will just push through and free this white portion in here. All right, so we've got that locking pin out, and as you can see, this white portion will just fall out. And what you see is that these are actually two separate switches here connected by this white piece here. All right, and so now what we have is a breaker that's free and able to be pulled out. So you're basically just going to push on one or two of these and raise the breaker up from the other side until it's free. Then you kind of move your wires out of the way and pull it out. All right, that's how it happens. It's a little bit difficult to do it holding the camera. All right, and so what I have here now is the new breaker, and I've bench tested it for continuity, and the continuity is all good. What I'm doing now is putting these little spacers on over the actual switch itself. It just makes it so that the holes line up when you install the breaker. And so you just put those on and they snap on in place. Now I'm going to set the breaker in here and kind of get it to sit down properly. And so I'm just going to sit this back down in here. And this is generally the part, especially when I'm only working with one hand, that I start using profanity, but sometimes you can get it to slip down in position relatively easy. Now, I'm going to tell you, I kind of pre-aligned that so I wouldn't have to struggle with it. But as you can see, it's sitting down flush. And now what we have to do is basically put the that connecting bar back so that this double pole switch will be able to function as a single throw. And so all we need to do is get that locking pin back in between the two switches with this white piece in between. So I'm going to put the camera down and do that, and I'll be right back with you. Now, I've always found that putting these little clips back on the locking pin, it's always been a pain in the behind. So I decided to grab something that I could actually clamp the clip with and force it on that way. You're going to be better off that way, or you're just going to be chasing this thing all the way around the room as it falls out of your hand and it springs off of the locking pin. So here we go. So after a little bit of a fight with this clip and some ingenuity, I was able to get it on and in place. Now what we're going to do is just basically go back and screw the Phillips head screws back in through the connectors and onto the poles of the switch. All right, so we've got all the Phillips head screws back on the poles and the connectors all connected the way they were. And now we're just going to test for continuity again. Here we've got one end of our voltmeter attached to the common bar, and we're just going to test the other side, which we weren't getting continuity with prior to the switch. And as you can see, we have continuity there. Well, as you can hear. And we've got continuity on that line 1 common bar that feeds all the switches down below. So for all the switches that are on, we're going to test them individually. This top one is off, and so I don't expect any continuity there. The next one has continuity. That switch is off. This one has continuity because it's on. Continuity here, and no continuity there. Okay. Yeah, so all the switches are on. This one is to the hot water tank, and it doesn't appear to have continuity through the switch. So we've identified another faulty breaker that needs to be replaced. But all the other breakers are on, and so we'll turn that one off, and we'll replace that at another time. The likelihood is that this whole boat is going to need a rewire. Just not going to need a rewire today.